Hello students, today we will start with the next chapter from Medicinal Chemistry 3, Semester 6, third year B Pharm. Urinary tract anti-infective agents. Okay, and as per PCI syllabus, only 13 drugs have been selected, and those 13 drugs I have written here under each class with black pen. So let us first see the classification of these anti-infective agents. They are mainly classified into four broad groups. Sulfonamides, trimethoprim first. Second group is quinolones, then nitrofurans and methenamine and its salts. Now sulfonamide and trimethoprim is not given under PCI syllabus under this chapter. Okay. So under quinolones, if you see further, first generation, second generation and third generation drugs. Under first generation, we have nalidixic acid. Second generation, norfloxacin, ciprofloxacin, ofloxacin, enoxacin. So you can remember it in this way, NCOE. Third generation, levofloxacin, lomifloxacin, gatifloxacin, spartifloxacin and moxifloxacin. Under nitrofurans, we have furazolidone, nitrofurantoin and methenamine and its salts. May only methenamine has to be studied. So that was about the classification. Let us see further. Before we move ahead, I would like to show you the questions which are usually asked. Okay, so these are some of the questions from the University of Mumbai question paper. So mainly they have asked us details about this scaffold. So basically you have to identify the scaffold, and after substitutions at these various positions which are stated in the question, you have to identify the drug, and then you can further talk about the targets and the activity. So basically main questions are asked on structure activity relationship from this particular chapter. Okay, you can see the other question paper also. Okay, so we will focus on the structures, how to remember the structures and all. Let us see here. First we can start with nalidixic acid. See, nalidixic acid here under quinolone, first generation. Okay, we are focusing here anti-infective urinary tract anti-infective agents. In that, quinolones, under quinolones we have all these drugs. Okay, first we will see about quinolones only. So nalidixic acid, the first generation drug. So this is the structure for nalidixic acid. I have written here the IUPAC name also. And you can see here the numbering starts from 1. So what is this structure? How to remember this structure? For that, you can see here, this is naphthalene, we all know now, and this is pyridine. Okay, now this naphthalene and N in the rings, that is 1,8 naphtpyridine. So we can see here naphthyridine. Okay, it is referred as naphthyridine, and the numbering is obviously from this heteroatom 1, 2, 3, 4, 5, 6, 7 and 8. So N present in this aromatic ring at first and 8th position. And now look here, the positions of the double bonds. So two double bonds were there no. Okay, basically 3 are there, but on this side 2 double bonds were there. 1 double bond gone because we wanted to place this carbonyl group over there. So how do we call it as 1, 4? 1, 2, 3, 4 at 4th position hydrogen, and first position hydrogen has come. Double bond has gone from here, no? Double bond has gone, so that valency of carbon has been adjusted by placing hydrogen over there. So this is called as 1,4 dihydro. 1, 4. This nitrogen is 1 and this is 4th. Okay, 1,4 dihydro, 1,8 naphthyridine. Naphtpyridine, here it is written as naphthyridine, and based on that, now this IUPAC, 1 ethyl, 7 methyl, you can see 7 methyl, 4 oxo, 1,4-dihydro-1-net naphthyridine 3-carboxylic acid. This is the name of nalidixic acid. So it's a synthetic quinolone, antibacterial agent with urinary tract antiseptic activity, and it is 7-hydroxy-methyl metabolite. Okay, so that was about the nalidixic acid. Then we have, you see here, further enoxacin. Now why I am taking this enoxacin structure immediately after this? Because you can see the similarity in the structure. See here, naphthyridine, no? Here also I can see the similar structure, naphthyridine. First position ethyl, here also first position ethyl. Here third position carboxylic acid, here also same. Here fourth position carbonyl group, here also carbonyl group. Now here 5 and 6, you can see sixth position fluorine, here nothing. 7 position methyl, and here 7 position has a bulky group, that is piperazine. So let us see now the nomenclature, that is IUPAC nomenclature. 1 ethyl, 6 fluoro, 4 oxo, 7 piperazine, 1 yl. So this numbering we have done from here, no? So therefore it is piperazinyl. 1,4-dihydro-1-net naphthyridine 3-carboxylic acid, very much similar to nalidixic acid. So nalidixic acid and enoxacin, okay, similar structure. Again, this is also the orally given drug, oral broad spectrum fluoroquinolone. This fluorine has come, no, very important, okay, very important, and therefore it is fluoroquinolone, antibacterial agent. For UTI and gonorrhea, the drug has been used. The adverse effect you have to remember is insomnia. Now next you can see here norfloxacin. Now this norfloxacin doesn't have N here. So what is this ring? This is quinoline. Among the 2 double bonds inside the ring, only one is here. So one double bond has gone. So at that place hydrogen has come. So it is 1,4-dihydroquinoline. So that 1,4-dihydroquinoline group is here. At 6th position fluorine is there, just like that enoxacin. See, enoxacin also had this fluorine here at 6th position, and at 7th position piperazine. So here also piperazine is there. 6th pe fluorine is there, 1 pe ethyl, and 3 pe carboxylic acid. So what is the name? 1 ethyl, 6 fluoro, 4 oxo, 7 piperazinyl, 1,4-dihydroquinoline, 3 carboxylic acid. I hope that is simpler now. The fluorine atom here, what they have observed, fluorine atom here increases the potency against gram-positive microorganisms. And why piperazine moiety has been added here? Because it increases anti-pseudomonal activity. Same applies here also. Piperazine, anti-pseudomonal activity is increased, and fluorine atom increases potency against the gram-positive organisms. Now let us see ciprofloxacin. Now the ciprofloxacin and norfloxacin, if you see the structural similarity, here also quinoline ring, I mean the 1,4-dihydroquinoline ring, and here also 1,4-dihydroquinoline ring. Again 6th position fluorine, 7th position piperazine, just like norfloxacin. The only difference here is the substitution at first position. Here it was ethyl for norfloxacin, and for ciprofloxacin, it is this cyclopropyl group. So look at the IUPAC nomenclature. 1 cyclopropyl, I have not given numbering now because now you have learnt the numbering. 1 cyclopropyl, 6 fluoro, 4 oxo, 7 piperazinyl, 1,4-dihydroquinoline, 3 carboxylic acid. Okay, these are the similar uses. So we have seen 4 drugs now: nalidixic acid, enoxacin, norfloxacin, and ciprofloxacin. Now see here the next drug, that is ofloxacin. Okay, before we go for ofloxacin, we will simple this similar looking drugs, that is lomifloxacin, Okay, lomifloxacin, the only difference here is it is difluorinated quinoline. Difluorinated, क्या याद रखना है, लोमी के लिए difluorinated molecule. So difluorinated, so one is at 6th position, this is the 7th position, and this is the 8th position. Okay, now you can see 7th पे piperazine is there, but piperazine में भी, piperazine का numbering we had seen, no, here 1 2 3 4. So piperazine के third position पे here methyl has come. Rest of the structure is similar. See, 1 ethyl, 6 8 difluoro, 1 4 dihydro, 7 3 methyl piperazinyl, 4 oxoquinoline, 3 carboxylic acid. Here along with UTI, it can be used for bronchitis also. It is the antimicrobial agent, photosensitizing agent, and anti-TB agent also. Okay, let us see sparfloxacin now. See, just like ciprofloxacin, you have this cyclopropyl group at the first position. Then the substitution we can see at 5th position also, 6th and 8th पे. Yes, already it is there. Piperazine में भी 3 पे methyl we had already seen in the earlier structure of lomifloxacin, and now one more methyl at 5th position. See here, lomifloxacin we had seen. Okay, see, first position ethyl was there, here first position cyclopropyl, just like ciprofloxacin. ठीक है, ciprofloxacin में जैसे था, देखो यहाँ पे, हाँ ciprofloxacin में था. Okay, so here at 3rd position methyl was there, here also it is there, but here additional 5th position पे methyl has come. Okay, these 2 fluoro groups are there, additionally one NH2 has come. So this is also difluorinated quinoline. This additional F they have added for increased photosensitivity. I mean, because of this fluorine, the photosensitivity increased. Okay, and to nullify its effect or to reduce the effect of this photosensitivity, they have added NH2 over here, which will decrease the photosensitivity. So they both will balance the effect of photosensitivity. So this is the name, 5-amino, 1-cyclopropyl, 6-8 difluoro, 1-4 dihydro, 7 at 7th position, no, at 7th position. You have 3,5-dimethyl piperazinyl, and therefore bracket has been completed here. 4-oxoquinoline, 3-carboxylic acid. Okay, this fifth amino and 8-fluoro counteracts the photosensitivity effect. But this drug has been withdrawn from the market due to high incidence of phototoxicity. It has been withdrawn. Let us see gatifloxacin. Gatifloxacin, synthetic methoxyfluoroquinolone. Okay, this is also cyclopropyl. This is there. This is also there. Again, 6th पे fluoro is there. 7th पे piperazine. Piperazine has methyl at 3rd position, but at 8th position OH3 has come. Okay, methoxy. Therefore, it is methoxyfluoroquinolone. 1 cyclopropyl, 6 fluoro, 8 methoxy, 7 पे it is 3 methyl piperazinyl, 4 oxoquinoline, 3 carboxylic acid. Okay, and the last compound here is moxifloxacin. Moxifloxacin, again see here, F is there, OCH3 is there, just like this gatifloxacin. Okay, OCH3 has been added in gatifloxacin. So same OCH3 here in moxifloxacin. But here it is not piperazine now, it is 2,8-diazabicyclononane. Okay. So this is this particular drug treats only bacterial infections, and this includes pneumonia, conjunctivitis, endocarditis, tuberculosis, and sinusitis. ये ofloxacin we had left earlier. So ofloxacin में you can see here one ring has been fused to the original ring. Okay, now पाइपराजिन इज ऑलरेडी देयर, पाइपराजिन के नाइट्रोजन पे, फोर्थ वाले नाइट्रोजन पे मिथाइल ग्रुप इज देयर, सिक्स्थ पे फ्लोरीन इज देयर. यहाँ पे जो OCH3 देखा था उसमें से सिर्फ O है, बट द अदर पार्ट हैज़ बीन एडेड इन द फॉर्म ऑफ रिंग. ओके, थर्ड पे कार्बोक्सिलिक एसिड इज देयर, फोर्थ पे carbonyl group is there. Let us see. This particular part looks like this, 4H14 benzoxazine, and now here the bond is not there, here bond is not there, so it is 4H23 dihydro 14 benzoxazine, and this is the nomenclature. Okay. 9-fluoro. Why 9-fluoro now? Because the numbering has been changed, no, as per the priority of the compound heteroatoms. Okay, as per the priority of the heteroatoms, numbering has been changed. So it has come at the 9th position now. 9th fluoro, 2,3-dihydro 3-methyl. Okay, so it will start from here now, 1, 2, 3, 4 and so on. 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9th position. 9th fluoro, 2,3-dihydro 3-methyl. 10 at 10th position. This has come now 10th position. Piperazine at 10th position. So what is there at the 10th position? It is 4-methyl. This is 1-, 2-, 3- and 4-. 4-methyl piperazinyl 7-oxo 7H pyrido 1,4-benzoxazine 6-carboxylic acid. Now this 1 and 8 positions of quinoline join to form 1,4-oxazine ring here. Oxazino-quinoline derivative. This comes under this category, oxazino-quinoline derivative, and this is used for mild to moderate bacterial infection. So this is how we have completed structures, only structures of these compounds. But now these all compounds, they come under one category of quinolones. Quickly we will see the mechanism of action of quinolones. These quinolones, they inhibit two types of enzymes, topoisomerase 4 and topoisomerase 2. Topoisomerase 4 is called as DNA gyrase. Now this quinolone inhibits this enzyme, but this enzyme, what it does, quinolones prevent the relaxation of positively supercoiled DNA, which is required for normal transcription and replication, and therefore they block DNA synthesis. See, topoisomerase is required for the relaxation of positively supercoiled DNA, and because of that transcription and replication happens, and because of that DNA synthesis happens. But quinolones inhibit this enzyme, therefore they prevent this supercoiling, and therefore they prevent or block the DNA synthesis. On the other hand, topoisomerase 2, this another enzyme. This enzyme interferes with the separation of replicated chromosomal DNA into respective daughter cells during the division, and therefore DNA synthesis happens. But quinolones inhibit this particular enzyme, therefore this separation, this replication of chromosomal into the daughter cells doesn't happen, and this is how it blocks the DNA synthesis. Now this DNA gyrase, this DNA gyrase has two subunits. Okay, so first subunit can cut one of the double-stranded DNA, and this is an energy dependent process, and this energy is provided by the another unit, that is subunit. Okay, this unit provides the energy to unit A, so that it can cut one of the double-stranded DNA, and this further processing will happen for DNA synthesis. Okay, but quinolones, they inhibit this subunit A of DNA gyrase. Okay, so mechanism of action of quinolones is inhibition of topoisomerase 2 and DNA gyrase, which is also called as topoisomerase 4. DNA gyrase has two subunits. Okay, so that was about the first part, of urinary tract anti-infective agents, that is quinolones. Next lecture mein what we will see? We will see this structure activity relationship.